Okay, checking audio. 1, 2, 3. Update the old stream title. There we go. All right, sounds good. I think we are ready to go. Ladies and gentlemen, welcome. This is the Discourager of Hesitancy streaming to you today on Compiler Day. Fridays is our variety day, and lately that's been compilers. And we are in the very early stages of compilers. We are in the Tokenizer generator phase. Now, I'm not saying that anybody else should do this. I'm not even saying it's right to do this. Writing your own tokenizer is not rocket science. It's a for loop where you go over every character and then make decisions based on what characters you see. Not hard, not rocket science. A million videos on it. But I like the pattern to NFA to DFA and then to a state machine generation. It's a fun, interesting problem that amuses me. So we do it, even if it's not necessarily the best way to write a tokenizer. So we write a tokenizer generator, which takes in a configuration file and outputs a tokenizer for us. That's kind of the goal, that's the plan. So if you know Lex or Bison or Lex or Yak, it's kind of in that suite of tools kind of thing, but we're going to do it a little different. One thing we're doing very differently is everywhere where I think that there's a performance impacting choice to be made, I implement it both ways with a pound define switch so that we can turn on and off different features and see how they perform later. For now, we're just going to test functionality and not actually measure performance until we get a whole bunch of this stuff built up and ready to go. So currently here are all the different options that I've been looking through. So the text buffer can use different methods to open. We've got the system level open, we've got the library function F open, and then we have the modern C++ F stream. We have different ways of iterating through our text buffer. One is using an actual for each with, iterators, begin, end, that sort of thing. And then we've got one where we just walk our way through the text buffer without all that stuff. I've thoroughly tested both of these, but the for each seems to work. This is where we'll be spending more of our time today. On Friday, we very nearly got the dispatch on switch done. So today I think we'll do the function pointer array, and then maybe we'll do a function pointer implementation today. Make sure both of those are working, all three of these are working. The go-to is going to be more fun. Like, this is where I think I actually want to go. This is where I think the high performance will actually be, but it requires more work. So we're going to do these other similar ones first. Token processing. For today, we're going to keep going with the batch method where we just accumulate all the tokens in a single vector. We may switch out that in the future to different types, but we'll get into that. And then we're generating our helper functions like, do we consume the next character? We call that munch. When we accept a token, is that written as a function or is it written as a macros? And that's kind of where we're headed. So we're just experimenting, we're having fun, we're playing, we're building something interesting, hopefully. And that's what we're doing. So today, like I said, we're playing around with dispatch. I think we've got switch done in a batch mode, and then we'll do function pointer array next. So there's the plan. And of course, I've been running around all morning. I have not actually heated up my water for my drink today. So I don't like starting and then realizing I don't have hot water. But that's where we're at. So let's talk a little bit about what we did last time. We got things more or less done, but we were getting a seg fault at the end of on Friday last time, and we didn't figure it out before the end of the stream. So I did cheat. I did off stream do a bunch of debugging. I tried changing copy constructors, assignment operators, because you're not guaranteed which one's going to be used when you're inserting into a vector, and so on and so forth. So I did a lot of playing around, a lot of logging. Didn't figure out what the issue was. I took out the vector, and I just put in a fixed sized array. And guess what? It worked. Like, this was literally the only problem. Nothing else was wrong. So then I put in an std list, and it worked. Then I put the vector back in, and it works fine. So none of the other changes I ever made any difference. And this kind of feels like the other compiler, the GCC bugs we found on these dates. So we can go check the journal for those in WordSleuth. But the compiler just is stuck in a weird state, and you have to make a code change in a specific location for it to get out of its funk. I think that's the only real way to explain it. Like, I took vector out, put something else in, it works. Put vector back in, and it works, even though it didn't work before. Like, that was the only change. So I figured it out, I got the problem done, which means that what you missed is nothing. Literally, I made no code changes. Right, we're back to std vector. It's exactly the way it was when we left the stream on Friday. So a couple of hours to get there that you didn't have to watch, where I was just frustrated with everything until compiler finally picked up the changes it needed. I don't know. So yeah, a little bit weird, but that's the way it is, I'm afraid, sometimes. Which brings us to today. We are almost out of September. Can you believe it? Yikes. It's like when I use GDB to debug, and it exits normally, but then cites false when I don't use GDB due to the way the GDB does memory style. Yes, exactly. Very frustrating when that happens. What that usually tells me is a value has been initialized to 0 by the debugger that I was not initializing. But yeah, the fact that it, in my opinion, a debugger should not add extra functionality like 0 initialization. So it should behave the way that the program normally behaves. Because oftentimes 0 means a null or a 0, which is like a default value in almost all cases. And so your behavior becomes normal. Unless your language actually does 0 initialization by default as well, then your debugger can. But anyway, that's just a personal opinion about the whole thing. So today, the task, we're going to dispatch our DFAStates in new and interesting ways. So let's go take a look real quick. So most of the code, actually, let's take a look in source. PV test parser. So this is the output of our current tokenizer generator, given a small default file. Like, let's see, I think we're testing against test dot. Here's our tokenizer specification. This is the name of the token. Here are the actions we can take. This will have to get cleaned up eventually, but X means discard this token, and L means increment the line number. So we discard comments, we discard white space, we discard new lines, and then K is for keep. That'll become default behavior eventually, blah, blah, blah. We do handle full UTF-8 in our regular expressions, and that's pretty cool. I don't see that in too many places. And when you do things like this \s, that includes a non-breaking space. If you copy paste things off the inner Googles, it just works. So let's take a look at what this file outputted. PV test parser. Okay. Yeah, where am I here? Source. There we are. So this is where we are. We're looking for the tokenizer. This is where most of our work is happening right now. So our tokenizer, we set a context. This is like all of the intermediate computations, and our overall system status exists. We set our context. So this is something we create. We set the file on the context. Actually, let's go ahead and just load up our test file. So to use our system, what you do is you get some text, you tell the context whether to copy the text or reference the text, or maybe you read it from a file. The context can also load files. Then you get your tokenizer and you set the context. So you're saying, here's the context I want you to parse in. So it has the text data in it. Then we sell a tokenizer to a process, and in this case, we're batch processing. So batch process just does it, and then we can iterate over the tokens that we get out of the context. So the tokens are stuffed into the context. So we're going to take that context and hand it over to the parser next, which will apply structure to our tokens. So that's kind of the flow. So the tokenizer has a list of states that we can go to. Here are some of the macros. This all gets very complex because here in these process switches, sometimes these things overlap. If you compute the number of different combinations, there's like 96 ways we could build this thing. So if you see helper macros and helper functions that look like they duplicate functionality, it's because they do. You have a different defined for each one. So up here, where if we've defined helper macros, they behave this way when we're batch processing, right? So actually it gets a little bit complicated to generate this code, but it's all for fun and for science and for the challenge of it. Anyways, so we're batch processing. We do that process, and we set up some initial state. Then we're using the for each, so we get our iterator. Here's where we end. Here's our current letter that we're looking at, our current character. Then we start a new token that says, here's the byte where the new token starts. Here's what line number it starts on and what character inside the line we start on. Then as long as we're not at the end, and then something similar here. We say, give us a character from this buffer. This is not like a begin end iterator. It's literally just a character. Maybe I should rename this to like first char or something. First char ref. Maybe that would be more correct. Oh yeah, code snippets. Tokenizer. Iter. First character reference. Then we have to go to the text buffer. Iter. Alright, there it is. Oh, there's spaces in between. Okay. First character reference. That's basically it. Okay, but anyways, back to our VB tokenizer, or test. There we are. So inside of here, we then start iterating, and whether it's a for each or a for loop, which isn't quite accurate anymore, but whatever. We dispatch our DFAStates based on that enumeration using a switch statement. So that's how we're doing it now. And I have some opinions about the performance that we'll measure later. So now we want to dispatch based on a different method. And I think we will start with the function pointer array. I can't really stand the weather lately. It's no longer real hot, but the temperature doesn't change. 73 and went down to 70. That's very stable, yeah. Oof. Yeah, that humidity is brutal. Where I am, it's not nearly that humid. Like 30% is about where we tend to hang out humidity wise. Unless you're, cooking in the kitchen, of course. That sounds pretty toasty. You haven't gotten to 30% years. Yeah, well, it's Jersey, so what do you expect, I guess, right? So I guess before we move on, go to test.cpp, I should demonstrate that it actually does run and generate things. So, oh, come on, stop it. Let's compile, clean, debug. Just let it completely rebuilds from scratch. You can see that I only cheated a little bit. Dog is being difficult. That's rough. Big dog or small dog? So there you go. If this is our text, hello space omega comma space world exclamation mark, and if these are the rules, vtoke, then we get 5 tokens out. We get the word world, we get the omega because the space is discarded. We get the comma because syntax is kept. We get world, obviously, skipping the space again. There's our exclamation mark for our last syntax. So that's what it looks like when it runs the way we want it to run. So I think what we'll do, we have to do 2 things. We have to declare an array of function pointers, and then down here we have to dispatch differently based on an array instead. So that's the plan for the morning. We get through that pretty quickly. We do want to do the just dispatch on function pointer. I think that could be an interesting one. I haven't tried that one performance-wise. So while Pat is chasing his dog, I'm going to go heat up some water for my drink. Heating up water. I can start it and yeah, whatever. We'll just get through that. Okay, be back in a minute. Okay, we are back. Make sure I turned the mic back on. Great. All right, now here's what we're doing. We're gonna make it do this same exact thing, but with pointers of function pointers. There we go. So we're gonna go to Tokenizer. So this is from our code snippets. Basically, this is code that is all boilerplate stuff. And when you see ... that means I'll insert code here. So this creates a chunk of code above this line that does things. And then, so emit this chunk, and then I take over and I say, crank out this enumeration here. I think one thing we want is called functional. So let's go VB project parser. Let's get functional in here. This is another code snippet piece, right? So these backticks indicate that I should look up this word in my dictionary and replace it with whatever when I wrote the chunk out, I can hand it a dictionary and say replace the word proj with something from my configuration. Okay, so we're gonna get functional in there. I have code in other projects. Source button. I could, no, not that one. So here we got functional, and then we immediately define an std function. Looks like that. Okay. So we've imported functional. It's one of the great things in... Is this public? Why is this public? Almost none of this needs to be public. Well, that's a good question, me. Huh. Oh, interesting. So here's batch processing. Here's the end of lazy processing, which starts here. Literally everything else here should probably be private. Right here. What? Oh, that's because of the accept. Okay, I see. Okay, that makes sense. I can handle that. I'm okay with that. Each. No. Oh, okay. I think we just do that. Okay, let's take a look at our tasks here real quick. We renamed text buffer iter to text buff dot first char. Is that what we actually need to do? We should be consistent with the names a little bit. Text buffer. There it is. Okay. So we did that. Move stuff in tokenizer.cpe into private. You want to simplify that interface as much as possible. Let me just try that, I guess. So test, let's see. Just make sure I haven't broken anything. This will take long to do a full build. Not with this program. No dependencies, so it's just my own code. Okay. Run it again. Works fine. So we didn't break anything. So we renamed text buff dot iter to first char ref. Moved tokenizer stuff into private. Okay, so small refactors as we go. So it doesn't become a big problem later. Okay, so here we are. We want to privately declare a data type. This one. So we're going to type def a void function that takes no argument as our DFA state function. Then we will declare if let's declare it after the enumeration. So if def, we're dispatching based on function pointer array. We want to declare a DFA state function array underscore DFA state functions of some number. We need a number. Some DFA states, which we have to pass in, equals something. end of chunk 2 DFAState function array, just so I know what's going on there. This is the end of chunk 2, so end of chunk 3, 4. Oh, okay, all right. I guess those were already numbered in the code correctly, if not done correctly elsewhere. So when we emit chunk 2, it needs this. So we go to our source, VB project. This is where we're emitting all of this code. We want Tokenizer part 1. Right, with replacements. This will be chunk 2. And the replacements are some number. Except that number is actually a string in our case, so we have to figure out what this string is. Yeah, I'll just do that. Do we have temp already defined somewhere? Okay. Star temp, temp. Let's just put it on the stack. We'll make it nice and big in case we need to do things with it otherwise. As printf into temp modulus the underscore tokenizer def. And we can get it the DFA. Which I think just has a vector exposed. So states.count, states.size. There we go. So that should output block 2. Then we're going to write out function pointer array. And we have this here. That makes sense, I think. Okay. So we're gonna, oh, the other thing we need to do. We're putting chunk 2. Means this is now chunk 3. This will be chunk 4. So actually, this whole thing is getting to be a little bit unwieldy. Like everything up until now is write out the header, write out the text buffer implementation, write out character reference, write out string reference, write out the text buffer, the context. Like these have no specialization at all. Then we hit this, and it's like the next. How many chunks are Tokenizer? Then we write out the tail end of the file. So I'm kind of feeling like this all needs to get into a function somewhere. Which makes sense. This is like the heart of the whole thing. Is this still a thing? Is anybody actually calling this? This looks like dead code to me. Oh, I see. Okay. So yeah, anything that requires much computation we've been breaking out. Okay, so I guess we do this here. Void, right, Tokenizer, CPP, we'll just break it out. Right here. There, that simplifies that quite a lot. Let me just dump all this in here. Just to keep it close to each other. It's all about code locality. When you're reading code, things that are near each other are better for understanding. Okay, so that actually cleans things up a bit. Okay. Let's see. This actually isn't really all that much. Well, let's just run this. Okay, we have errors. Oh, it's not a function. That is like Python mode there. What's going on here? Format. Okay. What? You know what? I'm just gonna cheat. I don't deal with that. Where's casting it to integer? Why you would ever have a DFA table with 4.3 billion objects in it, I don't know. Okay. So we run it just to make sure we haven't broken anything. But what we really care about, class Tokenizer. state ID. This should be private. I thought I moved all this stuff. This makes sense being up here, but I thought I moved everything down into private. Or not. Did the compilation not do the thing? So this is my tokenizer. I would expect, since we're not in lazy mode, we're in batch mode. I would expect process and something. In is done next to it. I should literally see set context and then this stuff. EV test. There we are. But it's not. This is the same code we had before. So what's happening with compilation? We load up our snippets. It outputs new code snippets. So where did they go? Huh? Tokenizer has 6 chunks. Token 1, token 2. Oh, those are. There we go. Tokenizer 1. This has not been updated. What's going on then? Set context. Then we're immediately into lazy. Oh wait, well, that's correct. Lazy or batch. Okay, so our code is in there. Three. Chunk 1. Chunk 2. Chunk 3. 4, 5, 6. Hmm. Write out chunk 1, write out chunk 2. Three. Four, 4. Okay. I'm putting chunk 4 twice, which is a little awkward. What? This does not correspond with what I'm seeing in my output, so what's going on here? Okay, end of chunk 1. End of chunk 2, 3, 4, 5. So yeah, there are 6 chunks if you count it that way. So chunk 1, as far as I can tell, has no backticks in it. Oh, just the 1. Huh. Did I screw up my Tokenizer code snippet file? What I'm seeing here is it should output. It has very little to do with what I'm seeing elsewhere. Tokenizer 1. Like this file is not being updated. Chunk 1, we have DFA here. So chunk 1 needs this. We already have the DFA. Okay, so code snippet 1 from Tokenizer. Right with replacements. But basically this. So that's code snippet 1 followed by ID. So let's check what's that Tokenizer. We need the start state ID, start state method, and the start state label. Okay, then we come to chunk 2. Which doesn't mean anything. Chunk 3 needs that. The end of chunk 4 is the accept. Yeah, this is fun. Okay. Okay, let me go to chunk 4. Chunk 3 only has one replacement. 4. 4 needs all 3 of those. And that moves down somewhere. And we write the accepts. Accept, then chunk 5. Then we write DFAState methods. And then 6. So the question becomes this switch. It's at the end of chunk 1 now. Oh. There's the dispatcher. And the state chunk 2, we output the state ID. And at the end of chunk 3, we write something. Okay. Okay. Yeah, Tokenizer is only going to get worse from here. Okay, it still works. Okay. Why is this state ID here? Why is this macros here? This is not at all. It's not what I asked for. Who's are we? Oh. Clean test. It should regenerate this file. So as part of the test make rule, it also does a debug build. So I forgot the test. Okay, now we're seeing stuff. Here we go. Okay. Okay. I suppose the state ID should be defined near the top, near that top type def. Okay. I think we can just do that. And it should work. I mean, work is a, oh, well, okay, all right. When here, we run it, hey, it still works. Now we as parser. Okay, we go straight into lazy or batch. Perfect. Switch. Okay. Blah, blah, blah. We're not testing that stuff yet. We do have our type def. We do have this thing. There's our context. And we need 9 DFAState functions, which tracks, oops, because here we have DFAState 0 through 8, so that's 9 of them. So that's good. Right here. We will output them there. Won't even be that hard, I think. Oh, we have 2 options. We have 2 options. We could do std bind and we could do std functional. Lambda. Do I want to break it down that much? We can. Why not? Let's do it. We're not in any hurry. We can go to performance switches. Function pointer array bind. Lambda. Wherever we define that. DFAStates as methods. No, I want state functions. Here we are. So found if defined. Oh wait. Array bind. Yeah. Okay. I don't want to create another chunk. But we can, if we must. Look where this is. Dispatch on lambdas. Okay. Just going through the little bit of refactoring here. Let's see, we had one example right here. Okay. Oh, yeah. These actually get kind of long, actually. Okay. But now, actually, we start to do implement. Here we are. Oh, never mind. We gotta find functions. Here we are. If it's bind or if it's a lambda. One becomes 5, 5 becomes 6. We're gonna modify things just oops. Okay. Trunk index equals the integer of this thing. We will cast it back to a code snippets ID. And increment. That way, when we reorder things, I think we know what it just automatically happens. Is that true? Is this easier to read or harder? back to the explicit. It was handy just a moment ago to go through my code and line up this number with what we were generating. Okay, so they both need that. So we're going to do 3 and then 4. They're going to be very similar. 5, 6, 7. Okay. All right. Like I said, we are going to generate over the next few months an awful lot of code. Okay, so what we're doing here is we're doing for each DFA state. In DFAStates. I think we also need to set our depth to, what was it, 12. So this to line up property 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. Writer set depth to 3. Go back to 0. Okay. If index equals DFA states size, we're gonna write things one way. With a comma. Or we can simplify it differently. I'm not sure which one's more readable. This thing, modulus s, comma, this is true. Nothing otherwise, comma. I don't know if this is any more readable or less readable than the other thing we have. It's shorter. Doesn't mean better. Okay, but we need the method name, which is this. Modulus 0, 3D. And that is index. This is the core of what we're doing, but if we're in bind mode first, then we do std bind class name this thing bound to this. So we also need the class name. Whereas this one you capture this, you just run this. Those should be fundamentally equivalent. So let's see if that outputs what we expect. Then we can worry about building it. So yeah, it's we're gonna get a lot of performance data out of this when we finally start running this stuff. Class name is not a thing we have. At that level. Where do we have class name? We do have it here. So we can hand that down. Now we have it. Okay. Got some warnings in our compilation. Let's go take care of those real quick. Oh, it's another size comparison thing. Okay, fine. We can do that. No, basically the same thing here. Actually, when we reset our index to 0, that's going to be a problem. Okay, try that. So we're going to generate these two arrays of lambdas or STD binds. Almost out of warnings. Oh. I guess we don't actually need the actual state, do we? Index less than DFAStates dot size. Index. Okay. Ugh. Value computed is not used. Oh. I don't know what this is called. Okay, so that should not break because we didn't change how we're doing it. But we can take out our new thing here. Somewhere in here. Oh. Okay, there's a broken thing there. So that needs to get fixed. This switch inside of accept. Good to know. Here. So since we're in STD. Oh. So here's the STD bind version. Here is the other one. change it. I don't know if it's more easy to read or not. Tokenizer. Put that there. And that there. And chunk 4 doesn't need that anymore. Oops. Okay, we'll try that. Then maybe text parser. I think that's a little bit easier to read. Okay, so I'm happy with that. We can now generate. I want to do something else a little bit different. In Tokenizer, near the top. Pound if defined. One of these two. Then I want to pound define this. That simplifies a lot of stuff. Because this doesn't care which kind. This one doesn't care which kind. This one doesn't care which kind. Okay. This one cares whether it's a bind or a lambda. This one does not. Okay, undef. If defined this thing. Undef this thing. Okay, phew. So we have, if we define helper macros, we have to define them here. Same thing here. Okay, so I think that's going to simplify things a little bit for us. We just need to make sure that still compiles and runs. Then we go to where we do the dispatch. So with the pound define, it's defined everywhere below that in the file. Well, the compilation, we'll call it a file for now, it's fine. The mental model is good enough. So it's defined for the rest of the file unless you undefine it. So to avoid name collisions later, when we're done with the thing, we can just undefine it below. Okay. DFA state functions, 9, etc., etc. We could make that a constant. That would be better. Is there like already a number of DFA states or something? And do we need it? Oh. Okay, so I'm seeing an issue already. Functions. Okay. There we go. If we're using a function pointer array, we start the array, and depending on which kind of array we fill it up, then end of that. Okay. That's better. Anything else here? Static constant. Oops. DFA state equals backtick non-DFA states. We can range check on this later if we want to. I don't think we need to, but you know, let's make the constant useful. That would also be inside this. Okay. Okay. Functions. Okay, so we have a static constant DFA state count. Blah blah blah. And then we define some number of states depending on whether we're using bind or lambda. Again, I'm more curious about how much any of these choices make. Like maybe the difference between using an STD bind and an STD lambda inside this, where every single character fires, maybe that's important. Or maybe there's another process that's heavier. Maybe this doesn't, saves a millisecond somewhere. Maybe it doesn't. I don't know. So we're going to test it because we would rather have empirical data than not. Okay, so I think this is ready to use. So when we go to our dispatch, based on this switch statement, this is what we need to add more options to. Dispatch switch. Come on. Here it is. If defined DFA dispatch function array, function pointer array. This is actually simpler than the switch statement because we've already done the work below. We can take how much for next state, which we will statically cast to an integer. And then it's m underscore DFA state functions at that thing, and then we invoke it, and done. That's, I think, literally it. Oh, which I'd already written here. Underscore root states. What is that? Oh, we stubbed it in. Maybe that later if you want to. Okay. So I guess we're ready to test it. We go to our makefile. DFA dispatch switch. DFA dispatch function pointer array bind. And we will just see if it generates that same list of tokens using the bind methods. One thing I want to do, let's see, is there a way, let's see, GCC output preprocessor file. Pretty sure there's a way to do it. Controlling the preprocessor. I thought there was a way to be like GCC dash something, like I or I thought there was a way to do it. GCC output preprocessor results. There we go. GCC dash capital E and then the file name. No std inc will bypass the standard include files. Oh, our includes. All of our includes are going to be in there too. I'm going to try it though. Let's just try it. Capital E is good. Oh, it's not that class name. It's Tokenizer. Good point. This is not our thing. Tokenizer. That. We no longer need to pass the class name. Okay, boom. So one thing we can do is look at what the preprocessor outputs for us. So I want to try it. Let's go. Go to the shell. Dash E of source VB test parser.cpp. put it to something, doesn't matter. And then we need the pound defines. So if we go to our make file, it should make it easier for us to narrow down what we're looking at in theory. Built-in command line, blah blah blah. So go to functions. And these are the functions. So that is just the std bind versions. Okay. If we do the other thing, instead we go with the lambda. Those are indeed lambdas. Okay. So this gives us a way to look at just one particular combination of pound defines and be good. So I wonder if that's something worth adding to our make file. So in here we run test. Sphincters. I don't think I have any included directories. We're not doing. Oh wow, okay. We're using it because we copy pasted from somewhere else, so we should remove that. Okay, that's besides the point. The point is we're going to run our $sign compiler. Sure, we can give it the base flags. No, we're just going to go -e. I'm going to copy this line in here as well. And our defines. Then VB test parser.cpp outputted to test parser dot I want it to be something that we can ignore, but that comes up with C++. And syntax highlighting. Basically, I always want to be able to pull this up and look at it. Let's ignore all files with underscore double underscore first. Okay, so next time we run this, it will just output that file for me every time. It doesn't take long. Whoa. Okay. Let's try that. Okay. There it is, right there. Boom. And there it's defined. Okay. So we have a way to get this trivially all the time. It's pre-processed. Really adds a lot of junk though. Look at that, 37,000 lines of code. When we're only generating 1,300, so it's tripling the size of our file after the preprocessor's done. Isn't that crazy? Crazy. But now you're learning a little bit about the C++ preprocessor. It's just text. It's just text replacement. That's all it is. Which is one of the reasons it can be so powerful and why it can be so dangerous. I'm going to kill that. I know that we are going to 100% put a .ignore in here for underscore files. Underscore star. Okay, so did not pick up that new one. We can remove temp.text. Okay, meanwhile, back into our build should be done actually. So if we go to our shell, we should be able to run this, and it should output our 5 tokens. So it works. So this is our function array as bind. We can change that. Do something else. Lambda. Make clean test. Okay. Times. So now VB underscore VB test. It should contain lambdas and not std binds. Nice. Okay. And then it should also run with all 5 tokens being generated. Perfect. All right, I think that that is pretty good, actually. Notes. Did a small bit of refactoring to get started. Added function pointer array to Tokenizer and can now dispatch with that. When building the array, it can use std bind or lambdas. Just specify one of the two. Tested both. It seems to, and it generates 2 tokens expected. Okay, awesome. So we can now dispatch on function pointer array index, which is pretty cool, I suspect. So here's my prediction. Oh, maybe we'll do predictions towards the end when we're actually ready to do performance testing. So actually, that's a pretty good place to call it victory. So let's get status, add. So we made changes to makefile. We did make changes to our project output things. Code snippets were updated, of course. And almost everything is in Tokenizer. Sure, git add everything. All right, we're going to commit. We're going to say dispatch on function pointer array is implemented and working. Done. Cool. All right. Where are we at? 2 o'clock. Actually, not bad. So the next performance switch to tackle Wow, we did not mark that as done. Okay. We've not been great about updating our journal here. Add everything. Commit. Amend. No edit. Okay. So in journal, we already said we're going to dispatch just on function pointer alone. We're not going to have an enumeration. We're just going to have a pointer to the next function. So we're going to pause there for a brief restroom break. And then we'll do that. We're back. So here's the deal. Even with us deciding to add a new branch to our computations, to our generated code, that did not take very long. So we're going to do the function pointer directly next. So there's no array lookup. And then we'll have to start on goto. And that will basically wrap up process batch. It would be better to mark these as actual things, as actual tasks. I'm going to call text for each done. I'm going to call, because it's been reasonably well tested at this point, we are able to chew through a file and be done. We've finished 1, 2, 3 now of those. Process batch has been working. We will have to do process lazy later. I think right now we're on helper functions, and those seem to be working. There will be. Do I want to mark these as done yet? They've not really been well exercised. Token again, like we're kind of down one path on this, reasonably well tested. This one reasonably well tested. For these cases, like this overlaps these pretty significantly. So marking these as done is a little bit disingenuous. But the helper functions are working. So the fact we have to add a few more branches on our pre-compile doesn't matter too much. Okay, this makes it a little easier for me to see where we're at. Okay, so we're going to do dispatch function pointer. And that's the plan. I want to rename this though. Function array. Function pointer array to just function array. I don't want the search to confuse me here, because function pointer, I want to be able to search for differently. Okay. So if we're in function pointer, the next state simply goes, let's see here, is that. Okay, I agree with those. If it's a function pointer, that's easy. Next state. Okay, that all seems to make sense. Except next state is declared here. And this can only be declared if defined function array okay. If we dispatch on switch, okay, if we're doing a switch or a function array, that's it. We don't need next state quite the same. So here's the function pointer. Which is define under these circumstances. Define dispatch function pointer. You have a state function. Next state. Okay. Okay. Oh, good heavens. state equals start state ID, start state method. Makes sense. These are the macros. I really have to exercise those. So if accept blah blah blah. Part of the text which is generated. Elsewhere. Inside the states themselves. Okay. Okay. Next, state equals a thing. Okay. So if we're in DFA dispatch switch, or DFA dispatch function array, dispatch function pointer, here. Okay, this actually raises an interesting question. So when we're in a function array, one time on loadout, it does the std bind or does the sd lambda. Here, every time we set next state, we have to do an std bind or a lambda here. Which is another place where we can get some testing. Okay, all right, here's a new thought. Performance switches. The function array function pointers description, making function pointers. Should it use std bind or lambda? function pointer find and it is kind of orthogonal to this, especially if it's not just function array that can get bind and lambda. So function pointer is also defined here. Anywhere else we use it, we would also hard switch at those. So I think that might be cleaner. Okay, so go over my mid file. Plus equals -d function pointer bind function pointer lambda. Those are the two options. Okay, so in Tokenizer, this goes away. It's not just DFA dispatch function array. Function pointer find if function pointers are lambdas, that should be it. Bind happens in one location, lambda happens in another location. That's basically it. So let's run that real quick. Oops. Oh, let's finish this in project. If def function pointer bind and if there se bind this. And lambda. Phew, okay. Yeah, I think that's it. One thing we're going to have to check is that we didn't break the array stuff when we separated the function pointer stuff. Okay. Runs. Lambda. There we go. Make sure that runs as well. Okay, that did run. Let's go back to bind for now. It doesn't matter too much. Then we want to look at VP test. Now we're generating more lines. So every time where we have to change states, we have to say, are we switching or are we going with the function array? Then we get the next state as an enumeration value. If we're in a function pointer type of operation, then we check to see if we have to bind the function or lambda the function. Blah, blah, blah. Oh, this end if is wrong. It should be, oh no. It should be this one. So let's do a quick fix up on that one. DFAStates function pointer. There it is. So if we're doing function pointers, check if we are doing bind or lambda. Okay, there we go. Boom. Now we test those two real quick. If that just works, then I'll be tickled pink. That means we planned well. Oh, it just worked. Oh, but we didn't actually test it. DFADispatch function pointer with bind. Now we'll test it. Actually test it. So we've included it to, updated it to like 186. I thought we did a binder thing there. Oh. Okay. I know what's happening. Underscore next state equals this thing. This is our problem right now. So if we dispatch on function pointer bind, we have to do things one way. And lambda's do it a different way. Okay, so we get those. Look at a function pointer. Do we bind or do we lambda? These macros are almost completely useless because none of it's been tested and it's probably wrong. Okay. Try it again. Okay. All in all, things are going pretty smoothly. If we have this done before 3 o'clock and debugged and running, function pointers. Oh, it worked. No way. And with a lambda? Should work the same. So did build, go to the shell. One thing I want to do while I'm in development. It's actually in here. I want to know exactly which defines are defined every single time. When I run it, what was it compiled with? While we're in development. Okay, so I have 3 runs left. 6. Delete. Okay, we're clean up. Then we're going to say pound if def and if I want to make this a function. Log defines okay. Okay. I'm going to search for pound if def, select everything. I'm going to say log note the thing. Let me search and F4. Okay. Bum, bum, ba-dum, bum, bum, ba-dum. Oh, good gravy. The notes came through. Oops. Okay, we're gonna search for parentheses, search for a close parentheses, and delete. Whoa! Oh, dang it. Alright. These are easy to clean up, so good. Okay, there we go. Defines. Okay, let's run that. Let's see if we get what we expect. Should be 5 or 6 undefined now. Okay. File IO F open. We're using the for each. We're dispatching on a function pointer where function pointers are lambdas. We're using processing as a batch, and we're using helper functions. Perfect. Okay. Okay. I like that. I actually really like that. Everything else is working, so I think we're in good shape. That function pointer went way too fast. Way easy. Added function pointer dispatch. We did separate the lambda bind flag out from the array, and it also applies to the function pointer dispatch. So like, here's the question. Is it more efficient to look up an index, get a function pointer to then call, but you only have to do the bind or the lambda creation one time? Or is it faster to, here's exactly the function you need, you don't have to do an index lookup, but you do have to bind it or re-lambda it every single time? I don't know what those cost. I'll be interested to see how those work. For testing, we also added some logging to test.cpp about what defines are active. Okay. Dispatch on function pointer is working. Function pointers can now be separately defined as bind or lambda. Independently. Boom. Yeah, that one went smoother than I thought it would. So that's good news. We are now dispatching our functions in so many different ways. So if we go to our performance switches, oops, we did not mark off this one. We did test both of those. This one is actually done. Oops. Oh, come on, what is it? CT. Okay. We should test text 4. We can just mark that as done. That's an easy test. It doesn't have any overlap with these other things yet. Batch and lazy are going to be a little bit rough, but it's fine. Actually, is that true? Yeah, we want to compare all these different things. So what are we at here? 3 times 2 times 4, so that's 6 times 4 is 24, 24, 48, 96. 96 times 2 is 192. 192 combinations of performance. We are writing so much more code than we need. This is awesome. We're going to know exactly what it costs us to make these choices. This kind of thing is easier if you start with it from the beginning, like generating this many combinations of code is actually a real big pain. But if you start with it and you build your functionality with this goal in mind, it's not that bad. A little bit of overhead here and there, duplication of effort, which will go away once you've figured out what the fastest possible is. Yes. So I have a couple of ideas around for each and for. Maybe we do that first. Actually, no, the for each needs to be the way it is. It's actually badly named. Do we rename them? We probably should rename them to be more easily understood. Text iteration as an iterator, text iteration as a character advance. That's probably more accurate. All right. Text iterator. And then Tokenizer is really the only place where that's going to matter. For each text iterator. Here's another for each. Those. Okay. The other one. Oh wait. Make file. Text for. We're going to replace with text iter char advance. Okay, so we said in test.cpp we were doing this. Tokenizer. And make file. Oops. Oh, it's not in here yet. Okay, so let's do a quick thing in build, make sure we didn't break anything. Iterator should be fine. I believe 4 is probably fine. We should try it with a few combinations of things. Oh, text buffer needs to know the right words. Okay. That's easy. Text buff dot cpp. Nope. 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 Okay. Text. Each with this thing. Okay. Make sure that works. Then we'll switch over to the character advance. Works. So text iter character advance. I'm really curious to see how all of our performance choices are going to come out. We probably cannot test each of them in every other combination. Even if I write a script to generate every combination of build and run them all. Run it, maybe I could if I run it overnight or something. Maybe it's not a bad idea. Interpreting the results might be a little tricky though. If I take like the bucket of the fastest and the slowest times and see what was in common, that would tell us which is the dominant term. I would be curious if like flipping this term gives better performance unless that term is also flipped. Like there's so many different things that could be very interesting to spot in that, but almost 200 combinations of code. Okay, so that works. We're iterating by character advance. So we can try some other combinations. Just to exercise the system. I don't think it matters, but dispatch on function array. We can use find. Let's just try a couple just to see. It might not be a bad time to also test the different function file loading operations. We tested this ages ago, but like there are other options. So instead of FO, it's just we have the system open call. Just to double check that we're not saying we've got it done without testing. It's been a while since we tested it, so we'll retest it. Seems to work. Open character advance switching by batch. Okay. We might as well try the other one over here. File IO F stream file stream. Yeah, one of the main reasons we're grinding through this is because I want to measure all of these options. Okay, so it seems to be working. That's with F stream defined. Good. So let me go back to some defaults. Okay. Whoa. Okay. We're still batch processing. Switch from bind. Those are all fine. Okay. Okay. Named text iteration. We did test that. Find and lambda are well tested. These we retested. So we're down to go to lazy processing helper functions as macros. So if we do the function the go-tos, that restructures our entire code, all of it. It's actually kind of crazy how much change it makes. I don't want to start that at the end of a day. But we are going to do that before we go to processing lazily. Which kind of means we are here. We want to run our helper functions as macros instead. What's our to do? Oh, that's a thing we need to do. We do need to fix that. Let's see here. Bug. This is an interesting task. Worthy project. Basically, we know it at compile time. Why would we pass around an integer when it can be a clearly defined enumeration and there's no range checking necessary? It has to be a valid value. So that is a good one. Actually, like that. This one is coming up. We're going to do that new line action. It's only that working. Okay. We did that. Those two. Yeah, these are the big items left. Let's see here, just about 3 o'clock. So the plan is we're going to do our helpers as macros. And then if we need to, we can do this one and maybe start on that one. Missing anything? Got almost 3 hours left of clock time. Honestly, I thought those other two would take longer, but apparently we planned out reasonably well. Or I'm just excited to get into the place where we're making progress. Once we get through here, I kind of want to go through this process. I do want to do this, but it's further down the road. This is dependent on that. Oh, we did this one. Oof, okay. That's basically the same task, just different ways of looking at it. Okay. Okay. So we have these two tasks we can pick up today if we don't get around to go to label batch processing. Okay. Ooh, how are we doing? I really do want to see those performance numbers. Which means we would have to have some very, very large files to test against. And lots of little tiny files. I'm thinking JSON would be a reasonable one to come up with for testing. Let's see here. Layler parser generator. Yeah, that's definitely a long-term task. Way out of scope for like the next several months because we are going to hammer this tokenizer generator until we're sick of it. Because it's, I think, the interesting part. Am I doing a full stream today? Yeah, I think so. Unless there's a reason to stop early, I don't see a reason to. with my baby girl feeling ill, I was thinking maybe taking some of my kids camping up at Grandma and Grandpa's house this afternoon, but with her not feeling well, that's kind of out the window. Because then my wife can't go to farmer's market with her, so I'd have to be home with her. So that's no camping out this afternoon. Um, so yeah, dadgum kids get sick and it just changes all your plans. I know you've been there before. So yep, full stream today. I like this compiler stuff, so I'm glad I'm getting some traction, and it's nice to have a breakup or mothers. Exactly. Basically, anytime you try to get something done, family gets sick. It's amazing. Okay. So I think a nice little cleanup of the to-do list is always good. Language design. Reveal the language name. I know the language name. We're not going to talk about it until we get to where we're actually building it. It's one of the few naming things I've actually come up with that I like. I hate naming projects. I hate all sorts of naming things. It's the hardest part of a project. Tokenizer. Parser. Semantic analysis. Backend. That is a whole discussion all on its own. Everything up to then is pretty not straightforward, but these are things we can work through. Okay, so small cleanup of our to-do list. Back to the old journal. So we're going to implement our helpers as macros. Okay, so rename text federation. Defines to text iterator and text iter character dance. Cleanup of to-do list. Tested text iter char advance. And then we tested function open, define flags to make sure those still work. Okay. Okay. What was my last one? Okay. Commit-m tested text iter char advance and retested file open define flags. Okay. Which brings us to helper macros. This is going to get, well, it already is messy. Because the helper functions do different things depending on which dispatch method we're using. And it'll get even more complicated when we go to lazy, because then it does other things in lazy than it does in batch. So there's a lot of overlap between some of these performance switches. So if we hammer this one out now, and we make it work with all these dispatch methods, and lock us in on batch, I think that's the right way to go. So helper macros. Helper macros. Helper functions. Oh, good heavens. This is what I mean. Like, this is a bunch of nested count defines based on our dispatch methods. Dispatch go to. Yeah, so this is going to be a mess. A big mess. That whole chunk right there. Go to batch processing. Okay, go to. Okay. We're not doing go to right now, but that's okay. Okay, so what we need is so one of the things that I believe is that for small, simple tasks like assign 3 things, the macro is going to save us a bit of time over actual function calls as here. So maybe we clean this up a little bit. Oof. Can we clean this up at all? Accept. That does nothing. We've already done this somewhere. Did we not? Our accept function does add it to context. What? I'm confused now. It's in the context, so when do we put them in the context? Oh, we need to fix this indentation. There it is, it's this. Okay, so this goes away. Doing switch and that. We're dispatching on a function pointer. If we're doing go-tos. So this switch, end of chunk 5. So we need to fix our indentations there. Tokenizer CP right here. Except push the case, write a bunch of stuff. Pop. That's all we really need to do there. We do want to generate code that is semi-readable. Like, there's no way that without building it up yourself that you're going to really parse through this file very well. Okay, so these all line up nice. Okay. You could collapse some of these. Not doing any lazy processing. Start a new token. Okay. Okay. So that brings us back to the old tokenizer. This accept method is actually going to be a big pain. So let's do the other ones. Start new token and new line. Ooh, well, that's fine. Can go up into the map. They shouldn't be any different. So start character equals current, start line equals line, character in line equals that. Okay, I'm okay with that. New line, just increment the line count. Character in line equals 0. I'm okay with that. Okay, Munch. Munch looks different in two different cases. Okay. So let's bring those up to Munch. Okay. Let's compare it. Okay. So here, if we're using text generator, our Munch looks like plus plus character in line plus plus iterator, current equals iter. So those all match. I think this is fine. Here the function matches the macro. This one plus plus character in line and current character advances. So again, this function is about the same as the macro. Okay. So our macro, it's the accept that's really gonna suck. And else. Let's be nice and explicit here. If process lazy. And if lazy. So process batch, process lazy. All the rest of these were fine. So we have to test against character iteration, and we have to test against batch versus lazy. We're ignoring lazy for now. Okay, so let's go to our except down here. Helper functions. Oh goodness. So we can't pound define defines inside of our macro. But we have, depending on dispatch, several different options. Oh, good heavens. Several options that actually work. The key part is this doesn't change. And starting a new token doesn't change. When we accept, we need a 1, 2, we need one definition, 2, and 2 subtypes, and then 3. This switch, though, should actually probably go first. No. No. It should. This needs to go first, but it moves our chunk, which means this has to happen somewhere else. Or not happen somewhere else. We need to pass that in on a different chunk. So the chunk 6 needs these, not chunk 5. Tokenizer CPP. So right now chunk 5 gets these. It doesn't need them. Chunk 6 will. Okay, I want to make sure that's generating what we hope. We're not losing track of which chunk we're in, which chunks need which words. We could just build the dictionary of everything we need and just pass it all the time with all of them. That is not the worst idea. Someone says like these things. 1, 2, 3, 4. Maybe that's what we do. Unordered maps. Let's see, what do we call that? Code snippets. No, it's in file writer. Write with replacements. Steal this type. Replacement map equals all right. And maybe we should have done this earlier, like a lot earlier. That's basically it right there. With replacements. That'll be easier to move those around. Anything else? I think that's a nice bit of cleanup there. You're using this feature enough. Just build a map, call it good. Okay. Where am I at now? Let me just see a thing real quick. Okay. So I think that's gonna work great. So we basically need 3 different macros for accept. Oh. Can we simplify it a little bit? We need to simplify it a little bit. Let's just make sure we're not broken. Okay, so here's what I'm thinking. This thing should be its own function and the macro can call it. I think that accepting a token is a heavy enough lift that a macro doesn't make sense. Like, you look at all these other things, it's like, here are 3 assignments. Here's an increment and an assignment. Here's 2 increments and an assignment. Like, these are tiny functions. The function overhead to advance a character is probably more than just using it as a macro. So this, though, does a whole switch and the actions. So I think we need an actual function called accept action, which can happen before helper macros, maybe. Which underscore curve, yeah, this thing. So accept action. do accept actions. 1, 2, 3, 4, 1, 2, 3, 4. Do accept actions. That's basically it. Which means chunk 6 needs those. So when we accept, now we can do accept actions as part of that. Okay. Batch has 3 different versions. And then start new token. Yep, it's going to get messy. If we're doing batch processing, and if we're dispatching on a switcher function array, we do that, that. But it gets more complicated than that because we need to generate a different accept for each of these cases. Oops. No, that's fine. So the next state equals that is the same, so that's fine. This one, on the other hand, needs this. And a backtick. Oh my goodness, hopefully it works. I'm generating different, except if we're doing lambdas. I don't like this ordering. Do it this way. Actually, start new token. Oh, what do I do? I don't remember if start new token is itself. Okay, so let's see here. If we're making macros, if we're batch processing, if we are switching, we're doing function array, we accept, we start a new token. Start new token is defined below here. We need to move these up. Oh, it's function. X do. Hold on. This thing needs to happen after the macros are defined. Is that true? No, it's not. It should be fine. Lambda, it's fine. Oh, good heavens. Okay. I suspect start new token. That's probably fine. Probably fine. Process lazy is going to be a big pain when we get to that one, though. Okay, we just try it. Is it time to try it? I think we've looked it over. Make file. Helper as macros. Okay, so an iterator versus character. That is one thing we do have to look at. And the 3 different currently supported dispatch methods. And the 2 versions of this. Okay. So character, dispatch, function pointer. Those are the 3 we need to test. Okay, there are some issues. Start new token was not declared at 990. That's probably correct. Token needs to be declared way near the top. Okay, that's one. Accept. A new line. Oh, we're going to change that as well this year. Tokenizer. Just to be consistent with the thing above. Okay. Fine. Now, what it's telling me now is all these macros have to be defined above process. Let me see here. This needs to go. Oh, no. Okay. All of this. Above lazy. Okay. There's still probably a couple of ordering issues we can fix in a minute. So let's just, oh, so let's just try it. But here we go. So if you define things in a class, the order you declare things, use things doesn't matter as much because the class has to be fully defined before it can resolve those references. With a macro, it must be defined above where you use it in the file. So I just fixed everything. We'll get back. I would expect start new token to be needed above that. Oh, I also expect, oops. Move this one to be consistent. Yeah, if only I could put these if defs inside the pound define accept, but that's not the thing. It's not possible. Okay. Do accept start new token. I kind of expect that start new token has to be above that. I'm actually surprised it didn't hate me. Okay. Okay. So if we run this and it works, we will be happy. If we run it and it doesn't work, we will be sad. Oh, it worked. So this is fopen text iteration by iterator. Dispatch my switch, pointer bind, process batch using macro for helpers. Okay, so let's do the other combinations. We said we need to test chart events. Because all of these things intersect a little bit, or a lot of it. We do want to make sure it's functionally correct before we can do any performance work on it. And it ran. Okay, good. Macro and switch don't interact at all, so it shouldn't make a difference. That would be interesting. Map out which performance flag interferes with each other performance flag. So for example, in these three touch nothing. They really don't. this mostly interacts with batch and lazy. Interacts with other performance defines widget flags. None. Okay, now. Iterator and advance are used in batch versus lazy. Process batch and process lazy. Okay. Function array and function pointer have interactions with function pointer. So process then interacts with all text here. And with DFA dispatch. And the helper and helpers. The helpers care a lot about where we're putting those. Okay. Okay, so the dispatch has interactions with process batch and lazy. Is this worthwhile? Maybe it's not worthwhile. That's independent. It only interacts with process. So process with text iter and dispatch. I'm not sure this is a worthwhile. Well, the bigger and more complicated this gets, the more I'm going to wish I had done this and kept this up to date. Because when you test, it's like when we test the file thing, none of the other settings matter. The file load protected or not, anything after that doesn't interact with it. But all the dispatch interacts with process, and these interact with this function pointer. All the flags have interactions with those two. That's basically it. No. I don't like this. Because what does an interaction mean? Like, let's not do that. Okay, where were we? Make file. We used lambda versus bind. I need to go. This one's getting old. Maybe a table. Maybe we should do a table of all the interaction. By interaction means within one of the pound defines, we have to also check another one. Like, is there overlapping pound defines? I think a table may be the right way to go. Okay. Okay, all the different dispatches. We did switch. Oh, we did switch. So the function pointer. Whoa. Where did I get that one from? I should find out. There's no exclude directories here. Just in my make file. Huh. Okay. Right, so try with a function pointer lambda. Not that one. Okay, looks good. Fine. Okay. array and find. Array and lambda. Seems to work. So let's go ahead and go back to the old iterator. Can't possibly, well, we could possibly test every iteration, but every version. Is that worth doing? Is it worth writing like a Python script to build everything in every combination and test it? That is not the worst idea. Probably not today. Right, I like the idea of being able to crank through the same config, the same test code text, and just make sure you get 5 tokens. Okay, so let's add that to our to-do list. I think that's a valuable thing. Automate testing every combination of performance on flag. Okay. Either way, I think macros is working. We didn't have any issues all that time. We're going to journal helper macros. Made some updates to helper macros, and it all seems to work for the combinations tried. Bring back the functions for now. Let's go back to dispatch on switch. Okay. Shockingly good progress. We did not mark that off. Okay, so shockingly good performance there. We've got another. We're at almost 4. We've got almost 2 hours left. Okay. This I like. And we do want to start updating line numbers. So let's start with this one. Let's just grab that into our journal. Honestly, these two are small and easy warm-up tasks. This I thought would be a lot harder. This I thought might not work as well as it did, but we did get it there. Once we separated out the accept actions as a function, I think that's just correct. It's a heavy enough lift that a function makes sense. Okay. All right, how are we doing? Current rule ID, Tokenizer, and VV project. Yeah, Tokenizer is by far going to be the biggest, most complicated piece we build for quite a while. I actually haven't done like a word count in a while, or line count. Probably should update that and check. Oh well. Alright. So in Tokenizer, m underscore current rule ID rule ID. So I have to define something like that. I tend to put those things near the tops. And chunk 3, this will be the rule ID enumeration. So just think of a bunch of these so we have alignment when we're looking through this later. Six, 7. Now there are 8 chunks you have to keep track of. Okay, so after the state ID enumeration, we do the rule ID enumeration. Because it's the rule, not the state, that determines what our accept actions are. So get a depth of 3. State DFA state methods, no. State ID, no. Rule ID, no. 3, 4, 5, 6, 7, 8 chunks. Okay, that all maths correctly. That is the something ID. rule ID number. We'll follow a similar pattern. We get our DFA. Our DFA states. Is there a way for me to have the rule IDs listed out somewhere and then sorted without resorting to a bunch of nonsense? Or we can just resort to the C++ modern container nonsense. Trevest, hello, how are you? I'm good. How are you doing today? You have to go right away. Just dropped in for a quick watch. Hey, you have a wonderful weekend too. Thanks for dropping in. Even if it's brief. Okay. So each DFA state contains a rule ID, I think. No, it's per transition. Oh. Or we can go back to the NFA. Does the NFA have rules? Okay, so this is actually not where I want to go. DFA state. Every transition in the DFA state can have a rule ID. So we want maybe a vector of rule IDs. Is that? Well, let's just. DFA state transition. In the state dot transitions. Let's collect them into like an STB list. It's fine. Oh, let's make it a vector. No, we want an unordered map. Can we do an unordered set? Okay, we're gonna try this. Rule IDs dot, let's see, what's it even called in a modern C++? Unordered set. And place insert and place how is in place different from insert? load of all these functions that is done. Whatever. Okay, we're just going to go with insert because I like that better than in place. Insert transition rule ID. Okay, then sorted rule IDs. I should be able to initialize this bad boy. Like a vector or something. From something begin, something end. Constructor. Iterator first and last. Okay, so that should work. Given rule IDs begin, rule IDs end. Sorted rule IDs. I think I have to have algorithm to sort a vector. So where's std algorithm? You have to just be project. Vector map. It's algorithm. Maybe our algorithms. Okay, C++ algorithms library. Nope, just algorithm. Sort. From beginning to end. Do I have to tell it? Using the default operator, yes, okay. So I should sort it. Then for int rule ID in sorted rule IDs, I'm gonna write something. Root rule ID, rule ID, oops. Last rule ID equals sorted rule IDs. That sorted rule IDs dot size minus 1. Rule ID equals the last rule ID. Okay. What are the odds? Root rule. We'll try it out. Okay. Set. Do I have a typo? Ah. Is defining header. Did I forget include type? Did I not put that in? Oh, under map. Okay. Else downstream of that is a problem. So okay. Step one, we're gonna just okay. If this is now the problem. Oh, -1. Okay, okay. That's interesting. Let's go take a look at what we're getting. So -1 means we don't actually do anything. It's like a not a rule. So that's fine. I'm okay with that. And yeah, that's going to break parsing from our corridor. So let's go take care of -1. Maybe it's less than 0. No. We do that. One small modification here. Just because nobody. I mean, rule 0 is never defined, but that's probably because of the. We can never transition to it. That's fine. Let's try that. It should be fine. What? I don't understand. Let's go to the step that's failing. It's dumping a stack of trace. Dang it. What if we don't write that out? So used, that's fine, because we just commented out everything that uses it. Okay, this looks like errors I would expect. Expected a bracket before a star. So what is going on in context? Oh. Okay. What is this? Oh. I think I know what's happening. There we go. Yes, I think we just had an extra and incorrect value in our string stuff. So I expect basically everywhere where it's talking about current rule ID, this is a problem. Yes, rule IDs are not integers anymore. Good. Which means everywhere we generate one, we do have to check things. So, in Tokenizer, let's where current rule ID, if it is not equal to, you know what? Cast int rule ID, done. Everything else is in VB project that does anything with this. Current rule ID. There. Rule ID. We should probably make that 3 digits. Back to here. What is 3 digits? Good. Actually, that's it. then the switch case. That's the other place where it has to happen. Oh, and we have to scope it. Root rule tokenizer. Okay. Huh. There's the switch cases. We would expect these to fail. Yes, blah, blah, blah. Okay, so we don't have to fix those. How is this? Oh. Rule ID. There we go. I'll fix that half. Case modulus D. Tokenizer. Rule ID. Root. Rule. Version 03D. That should do it. Oh. This would be way better in here. So basically that. Tokenizer rule. Lighty. Means -1 no longer is a thing. Vector. Definition. That's rule ID equals. All right, let's try this. Request form number, rule ID, pointer type. Okay. Okay. That's fine. Nope, 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 nope. Okay, that worked. Batch function. So if we go to VB test parser, we should now have rule IDs. This thing is a rule ID. The only way we can interact with it actually, that's a good question. When we start a token, why aren't we starting with a none? Rule 0, 1, 2, 3, 4. Okay. Rule ID equals that. Okay. Okay. Yep. All right, so that all looks good, except for this one. This one I do want a -1. -1, no rule ID, and it does need a comma no matter what. So there we go. Now in Tokenizer, if current rule ID is not equal to Tokenizer rule ID none, then we do that. Okay, I think that's reasonable. Then the other thing is where that switch is in accept. Accept function cases. For each rule in rules, but first we need a case for the none rule. Case original rule none. Right now, I don't think we're doing anything with errors. Maybe test parser. Logging an error is a thing. Okay. Could log the error. Are we actually using this yet? Let's log it for now. Log error. Format and whatever we want. Cannot accept when a valid rule ID has not been specified. Writer. Break. Writer. let's go take a look at how that looks. Okay. I think that's going to give us a lot of options here. Okay, so we just need to update that real quick. That gives us a lot more safety, a little bit of readability, a little understandability. Just pass around integers. It's not strongly typed, it's not range checked. We could range check it, but why don't we just use an enumeration instead? Boom, it runs, done. Okay. Pretty good. We still have an hour and a half left. We're cruising. We're cruising. Okay. Current rule ID tokenizer is now an enumeration. And that's basically all there's to say about it. All right, to do. We need to start tracking my numbers. That is a large enough task that I am probably going to pause for a restroom break so I don't have to do it in the middle of the task. So we're looking good. We're in good shape. Yeah, I think just a restroom break. I'll go do a snack run while I'm at it. Snack run, be back soon. Wow, I cannot type. Yeah, we're gonna take a quick snack break. Be back in a minute. Okay, we are back. Here's what we're doing. We are slowly building up our tokenizer to do all the things we need a tokenizer to do. And one thing we need a tokenizer to do is to give us meaningful line numbers, which it can do. But we want the text buffer to be able to give us any line number without having to iterate the whole file. When we're printing out errors, it'd be nice if we just say, hey, text buffer, give me this line if we've... Yeah, okay. Let me think about that for a second. So what is it going to look like? We've got 1,500 lines of code. Start new line, new line. I'm fine with that. But new line needs to do a little bit more. There. No, not there. Begin or in process. There we go. Basically here. Start new token. Could say pardon me. Start new line. so we're going to declare this char ref underscore current character reference underscore find start char. Ignore lazy. Let's try to forget cur. Actually, line start character equals cur equals. There. Okay. Okay. Now, when we say new line, I don't know what we call our text buffer right now. Define line or find the line. Spark Blues, this is Linux. No, this is Windows, but I install MingW, Sigwin, use a bash shell, run it all inside of Emacs. The less it looks like Windows, the happier I am. But if you're going to make our main project, Monday through Thursday, is a game. If you're going to make a game, easiest way to sell it is on PC. That's what we're going to do. So we're building it all on Windows, but I do IDE. This is called Emacs. It's not the best. It's not the ideal IDE, but it's the best one I've used so far. Yeah. Good old Emacs. In between game projects, I think I'm gonna do like a rebuild my Emacs from scratch one day. And also kind of here's how you learn Emacs, because it is a steep learning curve. But I think there's a lot of power in it. So yeah, feel free to pop any questions you are interested in. Let's start char and current. Question when I do new line. That's fine. Emacs is for Linux. How to run it on Windows. I will show you. Come over to where is it? Where is it? I haven't installed it in a while. I'm actually pretty out of date, but something like this might work for you. There are Windows installers or non I feel like that's where I got it last time. I went to the GNU page. The Windows section, there's a nearby GNU mirror. So probably got it from here. This is probably where I got it from. Emacs 29 is the latest, and then I just downloaded the not installer ones. It's like 29.4 zip, not the installer exe. You can do the installer exe, that's fine too. Whatever you want. Perfect. Exactly. Yeah. Welcome aboard. How's things going? I haven't seen your username in the chat recently, so I can't remember projects or anything you're on, but yeah, just feel free to drop any questions you have, and we're happy to chat about just about anything. We're making a compiler from scratch, so no libraries, just what's in standard libraries for C++. Even a lot of times not that, if we can help it. We're starting with the tokenizer generator, which is not the right way to do things. You can just write your own tokenizer dead easy. You just iterate over characters and make decisions based on what character you see. It's not rocket science. But I like this kind of problem. The DFAs, the states, the go-tos. We are going to build something a little bit crazy and weird that nobody else has built that I can tell. And we're building it with a lot of pound defines so that we can say, I don't know what the performance impact of this versus this is. So it'll be a pound define for all of the options, and we're going to make it correct for all of them. And then once we've got that done, we will then crank through permutations of performance settings and see how much each decision costs. So using a function versus a macro for certain types of operations, how much does it cost? Using a switch statement versus an array lookup, what does it cost? Using go-tos, what does it cost? We're going to measure all of it. It's going to be great. We have, I think, almost 200 permutations now that we'll have to test. But that's all just the fun and games of it. But right now we're trying to make it so that the text buffer can define a line. So basically we're saying the line starts here, and here's where it ends. And we need the text buffer we need to be able to ask the text buffer, hey, give us line 1, give us line 0. That's where we're at. So we're just adding some functionality to our text buffer. We were calling that define line. This text buffer calls to character reference. So, do I want text buffer or text buffer implementation to hold it? This thing knows about character references. The other does not, so we should stick it here. Yes, yes. So privately, we need some sort of container. You know what, let's not overthink it. String reference. We're just gonna make a big array to start with. So static const int max line number, line count, equals 100. We can replace this later with a vector or a queue, a deck, or a list if we want. Next line count. And then int underscore line count. We'll construct a text buffer. Our line count should be 0. Okay. Line count plus plus equals string ref from start to end. Okay. Then I guess we need a couple of options here. Int line count. Easy. And a const string reference. Line at int index. Just for lines. Assert that 0 is less than or equal to index. Now let's make this a multi-line function. It's big enough. Assert that index less than or equal to, oh no, just less than m underscore line count index. There we go. That's basically it. So I don't actually remember what these numbers all are. Is that rule ID and token ID? Oh, yeah, okay. Where are my new line characters being tested in state 0? I'm going to put in a new line character in our test text. This will blow up. And we'll say I don't know what to do with this character, which is a good test to run, but question then token. Yeah, so the line is actually a line index, not a line number. Okay. Line index. Okay. In theory, oh, at the end of file. I must have changed this in the wrong location. This should be, if it's not equal to, Tokenizer, rule ID, root, rule, none. Okay, so then the other question is, if line start character is not equal to current, then we do a new line. This is like after we finish processing the loop, cleaning up loose text at the end. About this. Line start character equals underscore current line character dot ends. I think that has to be done as well. Alright, let's try it out just to see what happens. confused, but we'll figure it out. Oh. Okay. Okay. I think we're getting close to having line numbers in, except that the regular expression is not correct yet. Oh, that's interesting. Okay, all right. And we know how to fix this context. Our buffer is not constant at this point. And we don't want to expose it to anyone else. So where we say buffer, we know it'll pass through here. Int define line let's go steal it from the buffer. Text buffer dot buffer dot define line. Start end return. What is the integer text buffer? Int. I don't understand what line count. So when you add a line definition to our buffer, it will kick back what the line number is. Assert underscore line count is less than text buff max line count. When it blows up, we'll know it's time to choose a data type there. Which means in Tokenizer, we just do that. Okay, let's take that for a test drive. Okay, to test it, we want to say text has some number of lines, which is context to dot buffer points to line count. over 1. Give me the old C string for it. 10. Delete 10. Okay. Let's just take it for test drive. We should only have one line in it. Oh, okay. Good old constantness. So close. Text has 1 line. The line is that. Okay. Now, if we put no new TF8, we put one at the end, this is going to blow up. And by blow up, I mean I don't think our current regular expressions catch the new line the way that they should. So it'll just say unexpected character. Oh, error 1. Very cute. Text has 1 lines. Yeah, because the DFA is not giving us the right stuff. But we plumbed everything in. I did not want to get into regular expression debugging at this point, but we may have to if we're to progress line counting. We're so close. And error 1 is not a useful error message. Error. We have 1, 2, 3 new line characters. And since we can't parse them out correctly, so what's this error 1? BV test parser. Huh. Okay, so this is the two states that can have an error in them. I see. Is this within state 0? Okay. Interesting. Do we always start a new token when we get an unexpected character? I guess we do. This behavior actually isn't the best. Okay, this is where we do it. This is not helpful. Per count. Error format string line. Okay, so it does all that for me. Lovely. Unexpected character at line something character something. Const char temp equals underscore current dot c string temp underscore line. Okay. M underscore line and where's lunch? And which character in line are we? Then we lunch, then we start a new token. And we delete temp. Maybe we'll get some useful output. Although the \n being unexpected is not going to help us at all. Boom. Unexpected character thing at line something. So that's all wrong. Expected character. Outline thing. We'll try that. Okay. Okay, so we need more. This. Okay, so okay, unexpected character at line 0. Oh, line +1. For some reason, people think of lines in terms of their number, not their index. So, and of course, we're not going to worry about formatting it yet, but at line at character 6, character 11, and character 19. So, 1, 2, 3, 4, 5, 6 is the 0. 1, 2, 3, 4, 5, 6. And there's a new line. 7, 8, 9, 10. The 11th character. 12, 13, 14, 15, 16, 17, 18, 19. Okay, so our character positions are correct. The lines are not incorrect because the regular expression isn't picking up the new lines on the first character of a token. And I think that's the answer. So, how do we fix our regular expressions? It's kind of a change in gear. Change in gear. Oh, what do I want to do? Oh. I think we are very, very close. I would like to know why some of our regular expressions are bad. So let's, I guess we're changing gears. We can't continue this. One line, there we go. Here's another question just for fun. Empty. The line count should be 0, and then it should blow up on the line 1 request with an assert. Everything else should work up to that point. Text processing begin. There are no tokens. Text has 0 lines, and then the assertion fails as expected. Boom. Done. Okay. We should really ask. count. Greater than 0. Then we can do all of this and not blow up. But it's working as expected, so not bad. The more predictable your program is, the better it is to debug. Processing begin, tokens empty. Yeah, there's no text, nothing happens. Great. It's just a nice little test to have in our back pocket. DFAStates. Okay. I think we're gonna have to comment this out and go do regular expression debugging. But we only have half an hour. Oh yeah. Another thing we kind of want to do here is define line. I want to void cast that. Say I specifically acknowledge that there is a return and I am ignoring it. Oh, but we don't have to. That's fine. Okay, so that ran. It runs. We're back in this state. So, regular expressions more or less had a new pattern not found in the start state. And we're not really parsing strings correctly. So, let's take this one out. Put that there. Add some notes here. So, text buff should now be able to track lines with string reference. However, we can't test well because of the regex bug, where new line is not in the start DFA start state. Changing tag to address this bug before testing can proceed. Boom, we will create a safe place to stop, get status, add everything. Text buff now almost supports lines, but blocked by regex. My regex bug. Save point to change tag. Okay. So in other words, like this is not ever intended to be a usable state of the program. We're just saving our work in case we break things horribly while we're trying to fix the regex. Which we will come over here into test.cpp. And mostly disable all of this. Okay, this has been well and truly tested multiple times. That's being tested above. The error messages we're not really using. No context that clear. context clears itself in the destructor. Clear. Oops. We should be able to do that. Okay. Now what? We're going to don't need to do that. This actually has very little to do with test itself. So we can do this. We don't need to change anything here. What needs to happen happens here. I can output. Oh, I don't actually get the outputs. Source main. Okay. We are logging the DFA. Let's log the NFA as well. Oh, we had different options for this, where it was log as a table. We could export graph visits for both of these. Would that be easier to track? Sure, why not? Export graph viz, and this one can also export graph viz. We're going to give it a file name. I don't remember if I give it an extension or not. Export. Nope, I don't. Okay. I think they're dot files or something. Is that what they're called? Okay, blah blah blah, and then I'll have to remember how to do it. It's been too long to use this. This will be NFA dot DFA dot. All right, dash project of s.vv project. Okay. Oh, we didn't rebuild. Debug. Okay. What? Export graph is not a const? That seems like a dreadful oversight. Export graph is const. Okay. Oh, now we run it. Let's see here. Graph is how to. Oh, I wish I. Did I keep that in my notes? Maybe I put it in my notes. That's what the journal's for, right? Graph viz. Oh, here we are. This one. Boom. Thank you. Thank you. NFA type PNG NFA dot dash O NFA dot PNG. We'll give it a nice big output. Okay, now we're going to do the DFA the same exact way. Okay, then we will open that. And we'll share the screen. So photovb DFA.png NFA.png. Okay. We can zoom in, but here we go. We're gonna share the right thing here. Is this photos? If I remember right. No, if I do have photos. Okay, so we're gonna share photos. Yes. Hello. Is it? Okay, just a second. We're gonna delete this source from what's it? Remove. We're gonna add a new source, window capture photos. And of course, photos doesn't come up at all. Why? It's not working for me. Well, shoot. Oops. So go over here, and we just make this full screen. All right. So here's the NFA. And there are some strange bad notations of our own. But it basically says we can get syntax, or we can get alpha through omega, or we can get alpha through omega as many times as we want, getting more alpha and omegas. Alpha through omega. Uppercase alpha to lowercase omega. That's the full Greek alphabet in one expression. Or we can get A through Ya in the Cyrillic alphabet as many times as we want, accepting. Or we can get A through Z English as many times as we want. Or get a comment, which is a hash sign followed by anything which is not a new line. This is not the caret there, and new line is the thing. So unfortunately, like I have a task to clean up the outputs of some of this stuff, but we're not gonna worry about that today. Or we can get a / followed by anything which is not a new line. So these are two different line comment formats. Or you can get white space. So I put an underscore for space, T for tab, and capital S for non-breaking space. And we can get as many of those as we want. Interesting. Okay. Well, and then or we get a group, which is either a new line or a group of, I don't know what that is or what that is. Oh, it's either a new line or a carriage return new line. And this can accept if we have no inputs, which is fine. Or so how is new lines not in our DFA? So let's go to our DFA. That's the NFA. When we compile it all down, this is the DFA. So the NFA looks correct to me, as far as I can tell. We could also do this as a table and look at states 2, 3, 4, 5. Just to make sure that it's saying what I think it's saying. Although this group, I don't remember, the grouping might not be necessary at all, including, since I construct this custom. I don't think I'm constructing this correctly. So the DFA, either we get, this doesn't look right for a DFA at all. Where'd all the rest of the stuff go? Start of line, this is not the DFA. Curious. DFA dot. This has all the stuff in it. Oh, I wonder, hold on. This is test ping, test DFA, test NFA. Okay, so we need to go this way. This is it. All right, so we come over here, full screen this sucker. All right, we can get, whoa. We can get white space in our start state. If we get white space, we can just keep on going through white space. We need a /. We need another /. And then we can loop until we get something that as long as nothing is a new line. This hash is anything until we get something that's not a new line. A through Z until we get something that's not an A through Z. A through Ya in Cyrillic. Alpha through omega here. And then, yeah, where did the new line go? It's just gone. don't think the DFA is properly processing the group operator when we transform it from an NFA. I think that's the problem. That's my guess. That's my guess. So let's look at it. Because I think the NFA is correct. Sort of correct. I need to remove some of these pings or something. Test dot, TSDFA. We'll keep these two around, but let's unclutter a little bit. Okay. We don't need stack dumps right now. We aren't looking at any of those. Right, just clean up the file system a little bit. Okay. So VB source. We want to turn the NFA to DFA converter. So one of the things is an NFA state can have a type of group. Now basically it should be a pass-through. Yeah. It's never addressed. In fact, I kind of don't ever want group to be a thing. NFA state to group. Can we get rid of that? We should write this in the journal. Initial look into NFA DFA from graph viz charts. It looks like NFA to DFA is not processing a group node. Either DFA should handle the group node type, NFA node type, or NFA should never contain, it should never present a group NFA state. I want to create this NFA point, I think. So when we're doing this NFA processing, so pattern to NFA converter group begins and ends. Oh, so this is in the case of a new line character. It's either a new line character or a carriage return, or it's a carriage return group, begin group. This is a concatenation instead of an all. So then those both get added together with an or group state, group, this group. Okay, so group state. End group. Fragment. I think we just skip this. I don't know if we need a group type. I really don't want a group type. Okay, to remove NFA state. To remove, we'll remove it once we're done testing. I think we just want the frag start state to stay the same. Reduce the top fragments and then push that on. I think so. Delete top fragments. Yeah. So that's one. What else do we do? Group things. We get a new fragment by reducing the top fragments, and then we put that back on the top of the stack. So this is another to-do remove. Okay. Here's another group. Where are we at? If we get a question mark, it's either a non-greedy modifier, so we have to get the previous state and mark whether it's greedy or non-greedy, or we can't add non-greedy if the previous operation is a group. If it's not a character or any, I'm not sure this is a true statement or a true check at all. Let's see here. We have a question mark. Anything that's one of these becomes marked as non-greedy. Otherwise, character, if the previous operation is between character and any. Okay, so what if we just eliminate group here? Let's, okay. And here, I just want to get rid of group, I think. So this is an asterisk, kind of the same question here. We copy paste, video remove. Just so we can compare what we had with what we don't have. I think we never want to store a group state. Once it's all reduced, it's a pass-through element, so okay, if we get a closing parentheses, get our fragment reduced from top fragments, which we popped off. So I think we just do remove this. We just push it back on. This start state doesn't change. Okay. All right. So in theory, we'll just see if it even compiles. Okay, so there are other things that need to know about group. And I think it's just DFAState. Group. Remove. Group. All right, we're getting close close to the time when I gotta log it off. So let me see here. If we go to DFAState. Well, group is no longer a thing, so I think we just got to one or more. Group. Alternate through group. Alternate, yeah. So everything except the group is an alternation. It just special cases of them. So if we get rid of group, that actually makes me happier. Instead of going to group, it goes to one or more. Remove. If this is removed, this really is a test for alternation, and remain can remain. Right, group goes away. Simply enough. Oh, there it is. You should never need to print that. All right. Let's see what we get here. Yeah, run that. We run NFA. We run DFA. We open those somewhere else. Let's close that screen. All right. Oh, I don't want that one. I want this one. Okay, if we go up to full screen, this last alternation, which was the new lines, now looks more like what I would expect. It's either a new line or carriage return, or it's a carriage return followed by carriage return followed by a new line feed. So without the group, that looks a little simpler. And now in here, our new line I think is here. This is our new line. Again, bad output on some non-printable characters. This is, white space new lines. We need to clean that up, but I think this looks better. So if we close those, we go back in here. Let's go back to just straight up Emacs mode because we're not looking at graphs anymore. We can do a full clean and test. So that'll build up a thing that has a new line character in it that we can test against, and the lines should process in that. Okay, so if we go to shell./source files debug db test parser. Oh, okay. It should at least log out the DFA for us. I think. Okay, white space, etc. I think that's a new line character. Could be that one. Okay, so I think new lines are now included. 3. Anything which is not that. 8. For some reason. Hmm. I don't want to rebuild, but okay. Oh, good heavens. So the DFA looks better if we assume that the printouts are just wrong. When we run this, it gets an unexpected character. So let's go look at what's actually generated here. Let's find process. Okay, here we are. Let's go here and see what it's looking for. Where are my DFA methods defined? Oh, it's not. Okay, that's why. Okay, looking for something like this with a 0. Okay. If we get a space, a tab, or a non-breaking space, we do things. If, okay. All right. So something is not being translated over correctly, and that's fine. We can fix that. This is supposedly the new line character. Is it? No, there's this thing. A through Z. So where did... / goes to state 2. Which is a / followed by anything followed by another / which then goes to state 8. Which is looking for anything that is not. If a state 3, if a state 8. Okay, so our assumptions were wrong. Okay, we've got to do some more debugging next week. We're going to pause there. I think that's the right move to remove the group. Let's go clean that up real quick. DFAStates.h. DFAState remove debug. We're not doing that. Okay. And then the other one was pattern to enable converter to do remove. Okay, so I think we're improving the old regular expression processing. We will have to finish debugging that next week. Again, Monday through Thursday is game development. We're in the artwork polishing layout phase. Yeah, somehow new line and \r is not showing up here. Okay, we will have to debug this next week, but thanks for coming. Hopefully it wasn't, actually got a good amount of work done, so let's go to journal. Removed group from NFA. Things still work, but new line characters still not in start state. All right, we're gonna save this. Remove NFA state. Operation. Everywhere. Still have a bug. Okay. We're going to pause there. Thanks for dropping in. Have a wonderful weekend. See you on Monday. Back to game development. We're going to lay out chalkboard maybe. All right. Have a good one. Bye.